Hi, everybody. This is Gigi from Kauai Community College. In this video, I will be talking briefly about probability. So it's just a brief introduction, and then we'll dive into more details in later videos. Okay, so let's get started. Okay, so introduction to probability. Let's get started. As always, we want to have some definitions so that we know what we're talking about when we're using these words, right? An experiment is a procedure that can be repeated, and it also have a well-defined set of possible outcomes. For example, when you are flipping a coin, um, can you repeat the process? Yeah, you can pick up the coin and keep throwing it. And does it have a well-defined set of possible outcomes? Yes, right? It could either be heads or tails, okay? And that is what we call an experiment, okay? Sample space is the set of possible outcomes of an experiment. So for the example of flipping a coin, the sample space would be heads or tails. And so we would say the sample size is 2 because it has 2 possibilities, okay? An event is a subset of that sample space. For example, the event could be getting tails when you are flipping the coin, okay? And the probability is how likely an event is to happen. And it is calculated by the area of the event divided by the area of the sample space. That if you talk about the sample space being geometrically formed, or you can, if you can count, then you would say it will equal to the number of outcomes of the event divided by the number of outcomes of the sample space. Okay, so it depends on how the information is presented to you, either in an area model or in terms of numbers that you can count. Okay. Now we have to distinguish between theoretical and experimental probability. Okay, so sometimes theoretical can be called classical probability, but in this class we'll use the word theoretical. Is when we assume that all outcomes are equally likely when we are calculating the probability. Basically, it is what you expect it to happen, okay? Whereas the experimental probability, and sometimes called empirical probability, but we'll call it experimental in this class. Experimental is based on the actual doing of the experiment, and it is calculated by what you have observed happen, right? So experimental probability built on the law of large numbers, which says that the greater the number of trials, then the closer the experimental probability will be to that true probability, okay? So let's take an example of flipping a coin, okay? As we said, that's an experiment, right? And theoretically, we would expect the sample space to be have a size of 2, heads or tails, okay? And then the event of showing heads would be having a probability of 1 out of 2, or we say 50%, okay? And that is what we call theoretical probability, what we expect it to happen, okay? Whereas the experimental probability is what actually happened. So for example, if you sat there and flipped the coin, say 100 times, and you recorded that heads show up 45 times and tails show up 55 times, right? Now, then the probability is what we call the experimental probability based on your experiment. is 45 out of 100, or 45%, versus the theoretical probability of 50. Because theoretically, we would assume that both heads and tails are likely to happen. Okay. So in this class, I think we would mostly focus on theoretical probability, although, you know, experimental is just based on what you observe, and it's calculated the same way. So it shouldn't make basically a difference between how you would think about it or how you would calculate it. It's just how the information is presented to you, okay? So here's the experiment of rolling 2 dice. Okay, so think about 2, and I would say fair dice, no trick dice here, okay? So just fair dice, and we would assume then that all the outcomes are equally likely, meaning we are in theoretical probability. And how do I know that the sample space has 36 outcomes? Let's take a look. Die 1 could have 1, 2, 3, 4, 5, or 6 showing, right? So that's the first die. Now the second die could be the same. Could be 1, 2, 3, 4, 5, or 6. Now, if you can see, that sample space is this rectangle right here of a 6 by 6 rectangle, right? And that is 36 possible outcome, okay? Now, let's see what events we are interested in knowing. Ooh, we want the sum being 8, okay? Sum means to add. So I'm gonna go ahead and add the faces that are shown on the 2 dice. Okay, so when we add, we would have 2, 3, 4, 5, 6, 7. So far, no 8 yet. Okay, and then 2 plus 1 is 3, 4, 5, 6, 7, 8. Ooh, there is one of the 8 that we're looking for. Okay, and then so keep adding 4, 5, 6, 7, 8, another 8, and then 9. 4 plus 1 is 5, and then 6, 7, 8, 9, 10, and then 5 plus 1 is 6, 7, 8, 9, 10, 11. And then we add 6 plus 1 is 7, 8 again, 9, 10, 11, and 12. So as we can see, the sample size is 36. So then the probability of getting a sum of 8 is, we would say 1, 2, 3, 4, 5 out of 36. And 5 out of 36, we would say, when you divide that, roughly 13.89%. Okay, and that's probability of rolling 2 dice and getting a sum of 8. Okay, here's another example that we normally see. Is this sort of thing here, right? Like if you are playing a game and you got to spin. The spinner has 36-degree red sector, 45-degree green sector, and the rest is blue. Now, suppose I asked you, what is the probability when you spin that spinner that it would land on red? Well, red is 36-degree out of the whole entire full circle. And we know a full rotation from our geometry section is 360 degrees. So 36 out of 360 conveniently is 1 out of 10, or we would say 10%, right? Okay. Now, what if I ask you, what's the probability of red or green? I'll be happy with either red or green. It doesn't matter which part it lands in, red or green. So then you would say it is going to be 36 plus 45 out of 360, right? And that would be 81 out of 360, we reduce that to be this fraction here, or we would say it is roughly, when you do that division, 22.5%. Okay, that is it for an intro to probability. It's a pretty fun unit, and I hope you enjoy that. All right, see you next time.